Before we investigate the statement, it's crucial to handle the meaning of what's in question. The enormous Hadron Collider (LHC), worked by CERN, marks a stupendous accomplishment in logical progress. Spanning over 17 miles, this refined exhibit of superconducting magnets remains as the biggest and most powerful atom smasher of all time. It fills in as an image of human innovativeness and the unprecedented achievements we've made in figuring out science. Amazingly, the LHC is able to reproduce the circumstances that existed during the absolute starting point of the universe. Anyway, as we venture into the infinite obscure, a significant inquiry emerges. Could this machine, which plans to uncover the universe's most profound privileged secrets, also open us to unexpected dangers? Founded in 1954, CERN is one of the world's most regarded logical foundations, with 23 member countries and an immense community of scientists. It fills in as a center for cooperative exploration and earth-shattering discoveries. Albeit the LHC is its flagship project, it is simply one piece of an extensive variety of molecule gas pedals and analyses. Think about it not as a course for vehicles or ponies, but as one for subatomic particles participating in a high-stakes competition to test the restrictions of speed, accuracy, and the very quintessence of reality. Inside the LHC, protons are accelerated to speeds approaching the speed of light, impersonating the energy levels that were present at the time of the Big Bang. The subsequent impacts reach temperatures that far surpass the center of the Sun. An arrangement of magnets directs the protons along their paths, while cutting-edge cooling frameworks keep the magnets at temperatures colder than space. These crashes are deliberately organized at 4 unmistakable focuses inside the gas pedal, where particular indicators, Atlas, CMS, ALICE, and LHCb, accumulate information. Every indicator has a unique capability, providing a different viewpoint on the consequence of these high-energy collisions. Together, they go about as tremendous cameras, capturing the aftermath of these accidents, with researchers carefully examining the debris to identify elusive particles, like the Higgs boson, frequently referred to as the God particle, and other phenomena that may enlighten the fundamental building blocks of the universe. By focusing in on subatomic particles, specialists aim to comprehend the very structure of the universe. Regardless, each new discovery at the LHC raises even more questions. The LHC isn't simply a machine. It represents humankind's unflinching curiosity and our determined quest for knowledge. It embodies our desire to figure out the forces that shape our reality. However, as we expand the limits of the unknown, we must stand up to the moral and existential dilemmas that come with it. What risks could emerge from testing the unexplored world? Might our journey for knowledge at some point release forces irreversible for us? At CERN, where the restrictions of human comprehension are being extended to their maximum, an unsettling realization has arisen, one that has agitated even the most prepared scientists. Brian Cox, a former CERN scientist and an extremely respected figure in particle physics, recently made a chilling statement that has both intrigued and frightened people across the globe. Cox uncovered that the LHC's intention is to reproduce a small-scale version of the Big Bang, essentially a little Big Bang. He explained the monstrous capability of the LHC to uncover historic revelations, such as deciphering the secrets of dark matter, a substance that comprises a large part of the universe. The chance of solving the key forces of the universe is undoubtedly exciting, yet it also comes with significant dangers. The mini Big Bang isn't just a theoretical idea. A real phenomenon happens inside the LHC. The collider recreates states of extreme intensity, pressure, and energy, reflecting the climate at the universe's birth. Maybe we are seeing the birth of time itself. However, with such tremendous power comes a tremendous responsibility. Consider the possibility that something goes wrong. This concern is not a new one. Back in 1978, Russian physicist Anat Borsky had an encounter that forever altered the course of his life. While working with the U-70 synchrotron at the Institute for High Energy Physics in Ingrad, Russia, a glitch caused a proton beam to cross his accidental path. The beam, traveling at unimaginable speeds, penetrated his skull, entering from the back and leaving through his nose. Struck by a flash of light brighter than 1,000 suns, Borsky remained conscious and walked to get medical attention. The fallout was both bewildering and unnerving. He lost hearing in one ear and experienced partial facial paralysis. Regardless of the severity of his injury, his mental capabilities remained intact, and he continued his scientific work. Borsky's experience serves as a disturbing reminder of the power and potential risks associated with particle accelerators. The dangers of machines like the LHC should never be underestimated. Some scientists have expressed concerns about the possibility of unexpected reactions that could alter the very fabric of reality. For example, there are fears that the LHC might actually create a microscopic black hole. Black holes are areas of space where gravity is so intense that not even light can escape. These disastrous forces exist at the edges of the universe, and the possibility that the LHC could create even a tiny black hole is both fascinating and alarming. Might such a black hole grow uncontrollably, eventually consuming the Earth from the inside out? CERN scientists have attempted to console the public, affirming that any black hole formed within the collider would be incredibly unstable and would vanish nearly immediately. Still, the remote chance of such an event has sparked significant debate and concern. To grasp how the LHC could create a black hole, it is important to understand the basic mechanics of a particle accelerator. When protons collide at almost the speed of light, the energy produced is so immense that it can distort the very fabric of space and time. To envision this, imagine a trampoline stretched tightly, with a heavy object dropped onto it. The fabric bends, and if the object is large enough, it can create a depression deep enough to pull anything nearby into it. This analogy gives a glimpse of how the LHC could affect spacetime on a quantum level, where the laws of physics become strange. A theory proposes that additional dimensions, beyond the familiar 3 dimensions of space and 1 of time, could exist. If such extra dimensions do exist, the LHC might have the potential to access them, creating a gravitational well that leads to a microscopic black hole. The possibility of this has drawn the attention of esteemed physicists, including the late Stephen Hawking. In his writings, Hawking suggested that the Higgs boson might become unstable at extreme energy levels, potentially triggering catastrophic events, such as vacuum decay. Sir Martin Rees, a distinguished astrophysicist, also raised alarms about the LHC's experiments in his book Our Final Hour. He acknowledged that while the chances of such an event were low, even a small probability justified serious consideration. The stakes are incredibly high, and the margin for error is razor-thin. CERN scientists have conducted numerous simulations and investigations, taking every measure to ensure the safety of their experiments. Brian Cox himself has addressed the concerns surrounding the LHC, emphasizing that strict safety protocols are in place. These precautions include thorough reviews to ensure that collider operations are done with meticulous attention to detail. According to Cox, the energy levels involved in LHC tests are far lower than those that naturally occur on Earth. Even if a black hole were to form, it would be so small and unstable that it would immediately dissipate, releasing energy in a burst, as predicted by Hawking's theory of Hawking radiation. Some have speculated that the LHC's experiments could open a gateway to another universe or dimension. Although mainstream scientists have largely dismissed this idea, it has captured the public's imagination. Few fantasies and rumors have persisted. What lies beyond our universe? Could we inadvertently release forces or entities we don't fully understand? The idea of parallel dimensions isn't new. String theory, a leading candidate for a unified theory of everything, proposes the existence of more than the 4 dimensions we experience, 3 of space and 1 of time. These extra dimensions might be hidden from our senses, but under extreme conditions, they could hypothetically be accessed. Imagine the LHC as a key, opening doors to realms that have remained concealed since before recorded history. When protons collide with energies never before seen on Earth, they could create ripples that test these hidden dimensions. While this remains speculative, it highlights the allure of the unknown. The potential of discovering alternate dimensions continues to captivate the public, even though most scientists remain skeptical that the LHC will open a portal to another universe, or, more ominously, to something far more terrifying. Should we be concerned about the risks associated with the LHC? It's easy to get caught up in sensational headlines and fears of massive disasters. However, the truth is that scientists at CERN are fully aware of the potential dangers, and have taken every precaution to ensure the safety of their experiments. They constantly monitor and assess their work with the utmost diligence. The potential benefits of their research, such as unraveling the mysteries of dark matter, discovering new particles, and expanding our understanding of the universe, are truly remarkable. These breakthroughs represent a significant leap forward in human knowledge. Yet, they do come with inherent risks. Like all great scientific advancements, the tests conducted at the LHC present significant ethical questions. Could the creation of exotic particles or the exploration of extreme energy conditions lead to unforeseen consequences for our planet or even the fabric of reality itself? These questions cannot be ignored and must be carefully considered in light of the broader implications of scientific progress. In conclusion, the Large Hadron Collider is a magnificent achievement in human ingenuity and curiosity. It has already led to groundbreaking discoveries in particle physics, shedding light on the fundamental functions of the universe. However, as we explore these strange realms, we must remain vigilant and aware of the potential risks involved. The quest for knowledge is one of humankind's most ambitious endeavors, but it is not without challenges. The LHC stands at the very forefront of scientific exploration, where theory meets experimentation and where the underpinnings of how we understand the universe are being tested. The journey of discovery is never without danger, and the LHC is no exception. It stretches the boundaries of physics, seeking to reconcile the fundamental forces of nature and answer age-old questions about the origins of mass and the nature of dark matter. However, as we continue to explore these frontiers, we must consider the profound ethical and existential dilemmas that arise from harnessing the forces that govern the universe. The risks of unforeseen side effects, whether for our planet or the very fabric of space-time itself, remain a challenge that demands thoughtful reflection. Nevertheless, the pursuit of knowledge remains one of humankind's noblest endeavors. The LHC's investigations, while perilous, offer us a glimpse into vast unexplored domains of science. As we stand on the precipice of discovery, we must approach this journey with both hope and caution. The LHC represents not only the pinnacle of human technological achievement but also a tremendous resource that has the potential to reshape how we understand everything, from subatomic particles to the most monumental cosmic phenomena. With each breakthrough, new questions arise, opening new avenues for exploration and contemplation. The path of scientific discovery is uncertain, but it holds the promise of revelations that could redefine our understanding of the universe, our place within it, and the very laws that govern reality. One of the most significant aspects of the LHC's experiments is the convergence of theory and reality. For years, physicists have wrestled with understanding the forces that govern the universe: gravity, electromagnetism, the weak nuclear force, and the strong nuclear force. The ultimate goal has always been to unify these forces into a single cohesive framework, a theory of everything. The LHC has played a pivotal role in providing experimental evidence and insights that bring us closer to this elusive goal. Its work not only advances our understanding of particle physics, but also holds the key to uncovering the fundamental truths of existence itself. The ethical dilemmas tied to these experiments are significant, but the pursuit of knowledge has always carried risks. However, when those risks involve altering the very fabric of reality, the stakes become tremendously higher. Could a single experiment at the LHC accidentally trigger an event we don't fully understand, leading to outcomes that are impossible for us to predict? This is a question that scientists, scholars, and ethicists continue to investigate. As we delve into these unfamiliar domains, we must remember the responsibility that comes with harnessing such immense power. Despite the potential dangers, few would argue against the pursuit of scientific progress. The rewards, new technologies, medical advancements, and a deeper understanding of the universe are immense. The discoveries made by the LHC so far have already changed the scientific landscape, from the identification of the Higgs boson to advances in our understanding of dark matter. These achievements have far-reaching implications, not only for physics but also for other fields that rely on this foundational knowledge. As we continue to push the boundaries of possibility, the LHC serves as a reminder that science is never without uncertainty. No experiment is entirely without risk,